the next chapter. That one is velocity, acceleration, and displacement.
Okay,
That
okay,
is
okay.
the next chapter. We are still in chapter 1, right? We are still in
Mhm.
chapter 1, and today we are going to talk about the Cartesian coordinates, or sometimes it is known as the rectangular
Rectangle.
coordinate system. Now, this
Okay.
one is quite elementary. Okay, I just go through with you. The Cartesian system has two dimensions. One is the x dimension, the other one is the y. Okay, so
Okay.
this will give us a pair of numbers. Okay, the two dimensions will give us two numbers, a pair of numbers. Now, this pair of numbers shows us the position of a point. Okay, let's take for example a point A. Okay, so A, where is the position of A? Oh, the coordinates are 10, 5. So it means that we move in the x direction 10 units, and we move in the y direction 5 units.
5 unit. Okay.
Oh, this is the positive direction. Where is the negative direction? Okay, let's say we have another point C. The coordinate is negative 10, 5. Negative 10, 5. So the first number represents the x coordinate. So we move in the negative x direction. So this is move. Oh, negative 10. Okay. So we moved on to the left hand side, 10. So negative 10 and positive 5. Positive means you move up 5. Okay. Let's say we have 5, 10, negative 5. So we move positive 10, then down negative 5. So for the x direction, moving to the left is positive, moving to the right is negative. For the y direction, moving up is positive, moving down is negative. Okay, right. So this is our uh, rectangular coordinate system, or the Cartesian system.
Okay.
Now, there is another system that we are going to use. Now, you know the throw, javelin, shot put, and what else? The hammer throw, the discus, and so on. Now, for this type of throw, you can see that they have drawn the thing as like a sector, like that, something like a sector. So from the center, the person stand at the center of the sector there, and he start to throw the javelin or throw the things like that. So for this, you want to measure how far they can throw. It is not it is not useful to define them using how many steps to the right, how many steps to the forward, and so on. So it is more useful if we define it in this polar coordinate system. Now,
Okay.
what is a polar system? Okay, this polar coordinate system is defined by two numbers. Okay, the first number is the distance from the center, the distance from the center. And the second number is the angle from the horizontal axis. So what am I talking about, right? So we look at this point B here, right? This point B. So how far is the B from the center here, right? So how far is B from the center? The distance of the green line, the green line. So the distance of the green line is 6.57
6.7.
units. So the first coordinate is actually the distance, how far. Okay, then in what direction is this B? Can you see this red line here?
Yeah, yeah.
Okay. So this red line is the angle between the horizontal axis and the line, the green line. Okay, so this is the second coordinate. The angle here is the second coordinate. Okay, and that angle is 64.18 degrees. So I can actually move this point B here, and you can see the radius, the distance between the center and the point B is 6.57 units, or meter. If it's meter, then it's meter, but the angle is now 144.9 degrees. 144. So it is, there are two numbers that define the position of a point. The first number is the angle, so you turn through an angle, then you shoot out the distance. Okay, so these are the two numbers, and they are the coordinates in the polar system. Now, if the angle is moving anti-clockwise from the horizontal axis, then if you move anti-clockwise from the horizontal axis, then the angle is negative. But
Okay.
the distance is always positive. The distance cannot be negative.
Got it.
So we look at this point A here, right? This point A. Now this point A is 1045. What does that mean? Positive 45, this is positive 45. Now what does that mean? It means that from the x-axis, I turn anti-clockwise 45 degrees, then I shoot out 10 units. Sometimes it can be 10 meters, or if it's not defined, then we just say 10 units. So this
Okay.
defines the point A. Okay, the coordinates of A, 10, 45. Right? Can I move this point? Cannot.
Yes. Oh, no, sorry.
Okay. Now let me show you a negative point. It is here. So this point is G. Okay, how to define this point G? Okay, you have to turn anti-clockwise 45 degrees, then you shoot out the length 9 units. So this point G is defined by two numbers. The first number is this one, negative 45 degrees, go anti-clockwise, go clockwise 45 degrees, then you shoot out 9 units. So that is the position of the point G. You want to know how they look like when it is converted into our horizontal units, our rectangular one, is like that. It becomes like this. Now it becomes like this, right? But if we use the distance, then the horizontal and vertical movement is not useful. We just want to know the distance. Distance from the center to B, distance from center to A, right? And let's say we want to switch back to the grid, the polar grid. This one will be more useful. This type of coordinate is useful for javelin, for short path, and so on, right? This type of coordinates. Okay, now we want to know what is the relationship between these polar coordinates and the previous one, the Cartesian. Can we convert from one system to another? The conversion, right? Can we convert from polar coordinates to rectangular coordinates, and back from rectangular coordinates to polar coordinates? Yes, we can, right? So this is
Okay.
the conversion. This is the conversion, right? I move these tools aside first. I move this thing to the side first. Okay, right. Before you do the conversion, you must know this, the definition of trigonometric ratio, right? This definition of trigonometric ratio, uh, we have done it at the lower form, lower level. However, I'm going through with you again lah. Okay, right. So how we define the trigonometric ratio? The definition comes from a right angle triangle. Okay, the definition comes from a right angle triangle. Okay, right. Let's say we have this r. The length here is r, right? And in order to reach from O to R, sorry, this point here, the coordinate here, we have to move a horizontal distance of x and a vertical distance of y. Okay. Now the r here, if this is a right angle triangle, then the r here is the hypotenuse of the right angle triangle. The longer side, which is opposite the right angle, is the hypotenuse. And we call this the length of this side r. And this r is consistent with the r in our polar coordinates, right? So in our polar coordinates, we also have this thing r, and we also have an angle from the horizontal axis, right?
Okay.
But if you consider this whole thing as a right angle triangle, then there is a relationship between this rectangular coordinates x, y, and r. Now, if this is the angle theta, then the length opposite this angle here, the length opposite this angle, this is the length opposite the angle theta, and it is called the opposite side, the opposite side, and it is given the symbol y, which is also consistent with our rectangular coordinate system. The vertical distance is y. Okay, then another side, we have another side of the right angle triangle. This side is the horizontal distance, and we call it x. Now this x is just beside the angle theta. Whereas the y is opposite the angle theta, the x is just beside the angle theta. So this side we call it the adjacent side. Adjacent side. So how to define the trigonometric ratio? The trigonometric ratio, let's say sine, S-I-N-E, the short form is S-I-N. So sine theta is defined as y divided by r. The ratio of y is to r. So what is sine theta? Sine theta is opposite over hypotenuse. Opposite
Okay.
over hypotenuse.
What
But
hypotenuse?
uh, if you use x and y when it comes to the coordinate system, but in other triangle, let's say if the triangle is like this, no, sorry, if if the triangle is like this, then let's say this is the hypotenuse, then this is the right angle here. The right angle is here, right? The right angle is here. Right? So
Mm-hmm.
we we have to know which one is the angle. Which one is the angle? Let's say if this is the angle here, then this is the opposite and this is the adjacent. So is the angle normally, the triangle is normally not so nice upright like this. It is only upright like this when we want to relate the two coordinate system. That's why we draw it like that, right? If we draw it like that, then the sine is defined as y over r. But actually, if you look at this triangle here, right? This triangle here, there is no y and r here, right? So we use opposite over hypotenuse. So this is the more general definition of sine theta. This one is the more specific one. Y over r is actually referring to our coordinate system. Right. Next one, uh, cosine theta. Cosine theta is defined as adjacent over hypotenuse. Adjacent means the side next to the angle. Adjacent divided by hypotenuse. And finally, tangent theta is opposite over adjacent. We should look at this opposite over adjacent. In this case, it is y over x. Okay, so the definition of trigonometric ratio is actually this. Is actually this. Now this three is actually comes from our coordinate system. This is more specific. This one is more specific, and it is specifically used for our coordinate system. But if you just talk about trigonometric ratio, then you have to refer to this definition here. Okay or not?
Yep.
Okay, clear, huh? Right. Okay, right. So how to get the relationship between our polar coordinates and the rectangular coordinates, right? First, we use Pythagoras theorem to relate them. Okay, Pythagoras theorem is a square plus b square equals to c square. So the sum of
Mm-hmm.
square of the side is the square of the hypotenuse. So this is Pythagoras theorem, this one, right? So this is the first relationship, right? Let's say if I want to, you are given the rectangular coordinate system and you want to find the radius of the polar system, then you use this formula here. Okay. So from r square equals to x square plus y square, right? We can take the square root on both sides of the equation and we say that the radius, the first coordinate of the polar system is the square root of x square plus y square, right? This is for you to convert from the rectangular system, okay, to convert from this rectangular system to the polar system. Very bad writing, drawing. Okay, we want to convert from rectangular system to the polar system, right? So if you are given the x and y coordinate, you want to find the r and theta coordinate. How to find? Let's say you are given x and y, you want to find r. This is how you use. This is how you find. The r is actually the x square plus y square, the square root of x square plus y square. Okay, now let's say you know how to find the r and you want to find the theta. So how to find theta? We know that the tangent theta is y over x. So what is the theta? What is the angle theta? The angle theta is, okay, is equals to inverse tangent. Inverse tangent means tangent negative 1,
Yeah. Okay.
y over x. I miss out this part, right? So
Mm-hmm.
oh, it's very ugly. I
Oh,
better
it's okay.
use I better use the writing here. How I'll use the writing here. So theta equals to tangent of no equal sign equals to, is there this such a function inside your calculator? Is there
Yes.
is
Inverse function. Yes.
inverse trigonometric function? So it is the
Yeah. Yeah.
inverse
We have.
function of y over x. Y over x. Okay, right. So this should be it, right? Now I put it just beside here. Then it'll be nice. Okay, right. So how to find your r? You just use your r as the r is square root of x square or y square. How to find the theta? This is how to find the theta. The inverse tangent of y over x. And over here we call it arctangent, ARC, arctangent, right? But I think we call it the inverse tangent of y over x. Okay, next, how to convert the polar coordinates to rectangular. That means if you are given if you are given the r theta, how to find the x and y, right? So this is the relationship. If your x is r cos theta, that's how you find the x. How to find the y? Y is r sine theta. Okay, so this is how you're going to convert from one system to another. Okay, now we look at